an interesting blog post on the web. And usually if I write a tweet about it, I do the research like who is the author of the blog post. Found out, okay, it's someone from Munich. Then I asked Bela, that's someone we should ask to have a talk at MunichJS maybe. And then Bela said, well, he's already speaking at the next meetup. So that's the third speaker. And you'll see in a second why I thought it was interesting.
Hi everybody, my name is Nidin Vinayakan, and I'm Senior Software Engineer at CHIP. Last 3 years I was working on WebGL and WebGL rendering, and end of last year I quit my job at 3D Excite, Dassault Systems, and I start contributing to 3JS, an open source project. Meanwhile, I have job at CHIP, but it's relatively very simple. So I decided to develop a global illumination renderer for 3JS, which is quite ambitious in JavaScript, but yeah, it works. The main challenge was I need to go parallel. Otherwise, I cannot reach that real-time performance in JavaScript. And I found out, okay, there is a workers. You all know workers enable some kind of parallelism at some extent, but the problem was we cannot do real parallel programming. When you send your data to worker, it will clone the data, or you need to transfer the ownership. Then in the main, the buffer is detached. So in the worker, we'll get the data, but we need to send it back. So the latency is very high. So you need to clone each time we send data to workers. Yeah, but recently, we have now shared memory. So shared memory introduced shared, this is actually how it's working before. We have main thread and worker, and we have memory for main and memory for worker. So when you send the data, you need to actually clone it. And with the shared memory, we have it introduced shared array buffer. Shared array buffer is similar to array buffer, but the underlying memory is shared between all the threads. Like it, we have a big chunk of shared memory, and main and each workers can access or read-write data simultaneously to the memory. So we can now reduce the copy and transfer delay. And we have new API called shared array buffer. So it's like this, simple, same as array buffer. But when you post shared array buffer, we don't need to transfer it because it's already shared between workers. If you include it in transfer list, it will throw an error because you should not do it. And there is a problem because JavaScript didn't taste real parallel programming. So parallel programming introduced a lot of new set of issues. One of it is race condition. In pure JavaScript perspective, race condition occurs when you try to read or write shared array from different workers at the same time. So final result will be unpredictable if you do it because there is no order. So maybe it's very depending on OS or depending on hardware, depending on the different implementation, you'll get different results. So it's really unreliable. So here comes the rescue, Atomics. So Atomics actually guarantee the operations done using this Atomic API. It will do it in an order. So when you do additions or subtraction, anything, even if you are doing it parallel, like at the same time from different workers to the same memory, it will guarantee that each operations occur in a specific order. So the final result will be predictable. So you won't get an unpredictable result. So when you combine different multiple operations, you need a predictable result. So atomics only apply to integer arrays, so you cannot do float atomics. So it's like this, you create an integer array, and using atomics you can add. So at the end, we sure get like adding 3 at the end. So for example, if you are not using atomics, we the same index from different workers. Maybe one get the value from the memory. At the same time, maybe it's the other worker set it to 1, and the first worker maybe it will delay it, add, and it store it, so we'll get 1. But we actually add 2 numbers like that. And yeah, a little demo. Yeah, before going parallel, you need to assess your code. Like if your code is really benefit from real parallel programming, because even if we have shared memory, we need to coordinate between all the workers. So in this example, I'm actually calculating square root. It's pretty simple. This much number. I'm using the block size that I'm sending 10 data to each worker. So now I have 8 threads. So when I run it, it's pretty slow.
318, speed it up.
I have a
Working on it.
so single thread actually completed after 700 to 60 milliseconds, but multi-thread still working because we are sending a lot of small data to worker. So it won't benefit from parallel programming. So we need to send big chunk of data to each worker. So let's try. Let's try this much block. Okay, now multi-threading is faster than single threading. So if you send very small block of data to worker, so you need to coordinate to all the workers. So it will be slow. So you need to decide whether your use case is benefit from parallel programming or not. Now the big demo. So this one. So here I loaded a 3JS scene, which is standard ray tracing model, Stanford Dragon. And in order to accelerate my ray tracing, I need to build a acceleration structure. Here I'm using KD3. It's actually a spatial split of vertices, so I can ray trace very quickly. So I'm going to build it. And in Chrome, it's taking so long. 5.5 seconds.
And that is code that you've written by hand, right?
Sorry?
That is code that you have written by hand.
Yeah.
All right.
Then I investigate why it's slow, because sometimes it gives different result. Sometimes 8 seconds or 5 seconds. So it's a point for Chrome team, because what I'm doing is I'm sorting a lot of float 32 and 64 arrays, which is very slow in Chrome, but in Firefox it's awesome. So I found out what's the problem, and I implement sort myself. I use quicksort, and which is faster, 3.15.
So you were the one who wrote the tweet about
Yeah.
Firefox? That was half a year ago or something, where someone never that race what?
I also have a measurement here, so it's the type sort performance. Integers are very fast, but float 32 and 64 is slow. It's not performing that well. Maybe you can look at it. Okay, anyway. So let's start the rendering. Yeah, now it's ray tracing. It's actually path tracing. So when you zoom a little bit, it's actually shooting millions of rays from the screen and bouncing to the scene and it's finding all the colors. It's, in the JavaScript world, it's really fast. So I achieved fastest ray tracing engine in JavaScript. So it is not using ASM.js or WebAssembly, nothing. It's just pure JavaScript and pure JavaScript optimization. And how I achieved this, I created my own language. So I created TurboScript for it. It looks similar to TypeScript, but types are must. It's not optional. So in TypeScript, types are optional, so you can skip types. But in TurboScript, types are must. If you don't give type, it will raise compiler error.
It's a completely static language, and a completely static kind of a dialect of JavaScript.
Yeah, yeah, exactly. So recently I added WebAssembly support and ASM.js support. So TurboScript can combine to ASM.js and WebAssembly, but I cannot check my render in WebAssembly because in WebAssembly you don't have shared memory, not yet. So in the next version, it will be nice.
Oh, you should run it in Canary. I think we have it on now.
Really?
No.
Oh, okay.
Oh, actually,
It's Canary, but I need to port something.
Our
So thanks for
team just disappeared. So.
Okay. So it's a simple one. So it actually generates this code, a lot of big chunk of code because I use GNU memory malloc for creating objects and deleting it. So in the class, see, so I create a vector class, and I can export its standard TypeScript dialect, and you can create new vector, and you can add it, and you can destroy it. So if you look at the code, I have somewhere here.
So your ASM.js must be really slow.
No, the demo you saw is not ASM.js because.
No, but using ASM.js, so you use block 32. At least if you compile it to normal ASM.js, then you use math background and everything.
Yeah, I just finished it yesterday.
Okay.
So there are a lot of optimization need to done. But basically, I have main two methods, malloc and free. It's like C. So I implemented a stripped-down version of GNU malloc. So there is no fast bin or nothing. It's just a continuous chunk of memory allocations. So it's referred to next memory, and it's set a bit for free. And if it's free, it will link to the next free, like it's basic. So in my design, I have an initial memory, so I copy all the global variables to the initial memory. And in the mem.alloc, it's not readable because it's ASM.js. And the syntax is not pure, but in Chrome and Firefox, it's a valid ASM.js. Maybe it's slow. I need to add more optimizations. And the TurboScript can compile to normal JavaScript, ASM.js, and WebAssembly. So this is ASM.js version. I'll show you my real. So this is the actual render use. So in here, I'm not using any ASM.js. Oh, sorry. I'm not using any ASM.js dialect. It's pure JavaScript. So I'm using float 64 because I will get very good precision on colors. If I'm using 32-bit, I need to I need to sample a lot of colors, like a lot of hits, because the precision is very low. With using 64, it's much faster because the color precision is very high. So I normally, it's my TurboScript actually compiling for normal JavaScript, compile to TypeScript because it's easy for handling classes and everything. Then that TypeScript compile to normal JavaScript. So this is actually compiled by TypeScript. So it's you can see some standard TypeScript functions here, like extend, and the hierarchy is using the same TypeScript. So this is my quick sort, which is faster than Chrome quick sort. And what I'm doing is I create an object and I store in memory. So my compiler will decide what alignment it wants and what's the pointer. So in TurboScript, as a JavaScript developer, you're not going to write in C to get more performance. But if you can write in a similar dialect, it will be very good to get your performance boost, but still living in the JavaScript world. So it will actually write all the objects into memory, and whenever you want an object or manipulate, you can actually access. So it will automatically generate all the optimized code like this. It's not readable, or it is not like SNGS, so still you can edit it because it's still normal JavaScript. So you can still read it and maybe change, or good thing is you can actually debug it very well. So if you write C program and compare it to SNGS or WebAssembly, right now there is no good tool or good debugging tool. So using TurboScript, you can actually compile same code to normal JavaScript, SNGS, and WebAssembly, and you can compare it. And if there is a problem, you can actually debug it. So it will be super simple. And yeah, and finally, the shared memory is now stage 4. That means you will get it end of this year or mid of this year. That's good news. And yeah, I think my runner is still running. Yeah, so over time, it's a path tracer, so it will sample continuously. So you can set a iteration. Now it's actually very nice. You can see the red color bleeding in the left, and also the nice shadows. Using WebGL, we cannot get it really nice because it's emulating real light, how the real light interact with objects, and it will actually reflecting like how the real light do it in the real life. Yeah. That's it for now, and yeah, you can see TurboScript is, you can tell it's same as TypeScript. So those who know TypeScript, it's almost same.
So maybe it makes sense to mention that usually if you use shared memory, you only have numbers. And with TurboScript, you have a lot more versatile data structures.
Yeah, exactly.
Can you quickly maybe explain what is available when it comes to constructing data structure? So you have classes,
Yeah.
float 32.
Right now, I only have class. I don't implement structure because structure is not familiar to JavaScript developers. So I implement only class because it's I don't see the real performance boost using only structure, because at the end we are actually creating a JavaScript object and accessing this object using a static functions. So even if I using structure, I need to generate like almost same JavaScript code. So I don't see any performance boost, and also for now only class. And we can use normal functions like this, and you can call this class. And if you export, you can also export class. So if you export class, it will create a constructor and all the member functions as a static function, like vector underscore new, vector underscore add, like that. So you need to, right now, if you're only using TurboScript, it's everything inside TurboScript. That's okay, because you don't need to worry about the naming conventions, because it will automatically call the appropriate functions. And you can also export only functions, like a new vector. So it will return a pointer actually. So I built a playground. So this is actually compiling WebAssembly. So you can actually run it. You can change here, and it will compile automatically. And I have a terminal here. So I'm actually invoking this vector 3 and adding it. You can run it. So you'll get result here. So if you look at the code, I have exports, which is actually a WebAssembly exports. So you can see all the functions I export. For now, I am exporting all functions to debug. So because when I allocate a memory, I need to know if the heap are correct or it's corrupted or not. So you can actually use heap pointer, so it will return current heap pointer. You can create new vector, so it will return a pointer to this object, and you can create other. Then you can add it.
Larger font size.
Okay. So you get another pointer. So I wrote a JavaScript function vector to string. So if you, you get the real result. So in the vector 3, actually, I'm accessing real memory, like float memory, and returning it as a string. So if you're writing everything in TurboScript, you don't need to. It will be fast because it is not doing any, it's not creating any JavaScript objects. So it is not garbage collector language. So you don't need to worry about GC pose. So, but you need to manually delete the objects, otherwise you will end up with a full of memory full. But I aim it for maximum speed. It's not for lazy programming. It's for fast programming. So if you need fast programming, you need real, like V18 node. It's a big.
You're cheating. You just use a type array.
Yeah, it's like an SMJS.
Yeah.
I'm allocating a big heap, and I'm writing everything into the type array.
Yeah.
Yeah.
Yeah, you basically map objects to the array buffer.
All right. Yeah. And normally we have shared array buffer, so you can share memory. But if you really need to program like primitively, you need to manually write, like set the type arrays. That's very painful for big projects. So if you have something like this, it's much robust and easy. Because right now, as a JavaScript developer, we don't have anything like this. You can write in C++. Only now it's only available with C++ and EM scripting. You can compile JSON or WebAssembly, but there is no other language. That's why I decided to write my own.
Or to be fair, you can.
Yeah, but means I saw a lot of discussions about like compiling to WebAssembly, but I didn't saw any real products.
There was a research project that was called LJS that basically was a similar idea, but that one was abandoned.
Yeah, I saw it because their website's also not live now.
Yeah.
Before starting it, I searched a lot. I found LLJS, but I found LLJS like it's more C oriented because they create or recreate C in JavaScript. Most of JavaScript developers doesn't know C or they don't like C, because that's why I create like JavaScript talent for fast programming. Okay. And yeah, little benchmarks. So for Stanford Dragon, just to initializing, like to building KD tree before shared memory and TurboScript, it took almost 1 minute because at that time I have 8 threads, but I need to build KD tree in all threads because I cannot share my KD tree because I need to build KD tree in all threads. So it will increase the time 8 times. And also if you want to get the data, it's also I need to spend a lot of time to clone the data. So with the JavaScript in Chrome, it was 8 seconds, but
What was it? Is it Vesm or is it SMJS?
no, this is actually pure JavaScript. But before
No, I mean the JavaScript. So what do you compile?
to normal JavaScript.
To normal JavaScript.
Yeah,
Okay.
normal JavaScript. Right now I can compare JS, but I didn't try the render. Near future I'm actually porting because I actually developed JavaScript from Flat.js. The Lars T. Hans developed Flat.js. So I developed based on that. So my render is not compatible with JavaScript. I'm actually porting now. Then I can actually do a benchmark on SMJS, normal JavaScript, and WebAssembly. In WebAssembly, only single-threaded. Maybe I will find some way because they said when Chrome Canary shared array buffer is up with WebAssembly.
Should be soon. Maybe it is already.
I will try.
This quarter.
Yeah.
I mean,
You mean shared array buffers?
Yeah, that's it.
for Vesm.
And thank you for all joining this meetup. And thank you for MunichJS and Nidin. And I'm a tutor and our 01 alchemist. You can follow me.
Years ago. Seems so.
Okay, any questions? Okay.
You should be using float64 arithmetic in Chrome when you compile to SMJS because our float32, we don't benefit from the f round that you add around it. So you generate, I saw you generate a Vesm code, SMJS code that contains float32 arithmetic, but we don't recognize it. So what you do is instead, in Chrome, what you get is you do a plus b in float64 and then you truncate to float32. Then you go back and do float64 operation again, and then you truncate again.
Yeah, but by
So in
spec.
Vesm you use it. Yeah, but you can still use the full. Yeah, you're right. If you want.
because no, it's very confusing because sometimes Firefox gives one error and Chrome doesn't give error. Sometimes Firefox gives no error, Chrome gives some other error. So I use full spec. So yeah, it's with lengthy code. I'm using unnecessary type conversion. Yeah, I need to.
Yeah, so for full performance, doing this type conversion now in SMJS is actually hurting your performance in Chrome.
So if it's a float 32, I don't need to use f round
You shouldn't use
Shouldn't.
f-round.
because it will go back to.
So what
64 then.
Firefox does is basically if you do a plus b on things where Firefox knows, okay, the inputs are float32, and you f-round the result, and if Firefox will do the operation on float32, so it will do float32 add instead of float64 add and then truncate. But
Okay.
what we do is we do float64 add and then truncate. So we do
Okay.
2 operations, and this is on the processor pipeline. This is not beneficial.
Okay.
So Vesm fixes that, or Vesm gives you the expected behavior.
Okay.
With SMJS, you currently don't have it.
Yeah, sure. I will share my benchmarks after.
And that's the next question. You can turn this into kind of a benchmark, maybe?
Yeah, sure. And any other questions? Okay.
How did you achieve the performance optimizations in your compiler versus pure JavaScript?
That actually I need to benchmark my SMJS because right now as I said, I just finished yesterday the export of SMJS. So I need to complete my porting of my render, then I can compare it between two. And in pure JavaScript, it's just a Chrome optimization.
One last question, and then afterwards we can take the questions offline. You can talk to him, and we have more time anyway here. So yeah.
So one question regarding actual parallel programming. So what this will do is take a turbo script, will actually take some JavaScript, put it all into those shared buffers, and run it parallel on as many workers as you have. So does it mean that if I just take any JavaScript, my own code, that you'll try to run it in parallel? Or
In normal JavaScript, you cannot share objects. You can only share like type arrays or shared memory. So you cannot share a JavaScript object with the other thread.
yeah,
I know it's not possible.
I'm aware. I'm just saying. So if I yeah.
But you can actually take your JavaScript code and put it in type or make it as TypeScript, JavaScript. But you need to strictly specify the types. If it's int or
Yeah, and depending if I let's say I do that, and then basically, but yeah, I don't try to do anything in parallel, so I don't get any benefit.
yeah, sure.
But would it be faster just to put it into basically into a TurboScript?
No, because in my case, I have a scene, and I
So
need
basically the optimization that you get is because you do the work
in parallel. Because I am you can see
both
the
sides, yeah.
you can see it here because I'm splitting this
Yeah, that's just running one try.
because I'm splitting the render scene into different tiles, pieces, and it is actually calculating or tracing 8 pieces at a time. So in this case, I will benefit from parallel programming.
Because you
I'm sampling the scene 8 times at a time, 8 times at a time. And maybe for big data or data processing, if you have big data, you can actually do it.
All right, that was it. So the general idea is if you do number crunching, you code it in TurboScript, and you have an easier time doing it as if you did like some weird hand coding and encoding and so on. And you have more freedom because you have more data structure than you would have if you always had to use just typed arrays. All right, thanks for your talk. Thanks for attending. Don't go away, stay. We have more time. We have until 11. So stay around, there's still food, socialize, and don't go away.
Several websites just to edit to my answer video.
Alright, so yeah, this is part of the offline, so, and then people are interested, just go up here.
Actually, it's just the answer to your question. Just the framework, the German framework. Here, file. It's built using this. It's built using this node interfaces. But doing that